Alright, so now we're going to be talking about law of sines again, but now this is for the case of SSA. So this is used when you're trying to find the angles of a triangle. And they have a little side note right here. Look at this. When you are finding the angles, it's possible to have one solution, two solutions, or no solution. This is called the ambiguous case. Not too important to know that, but it is important to know that you could potentially have more than one solution or no solution at all. So, the sine function always has a range that is going to be in between -1 and +1. If the sine function is going to be positive, then the angle can lie in quad 1 or 2. So then by default, if it's negative, it would be in 3 or 4. To find the other possible angle, you would subtract from 180. And again, this is if you have two solutions to your problem. The sum of the angle measures in a triangle is always 180. The three angles of a triangle always add up to 180. And therefore, no triangle can have two obtuse angles. And just a friendly reminder, obtuse means it would be greater than 90. So you can't have two of those. It's just not possible. So let's do an example here. So you're actually going to need to draw the triangle. So just do a little rough sketch of a triangle. I'm going to call it A, B, C. They tell you that angle A is 50, the side AB is 4, and the side BC is going to be 9. And we need to find this angle right here, C. So I'm just going to call it X. So now use the law of sines and set it up accordingly, because the 50 and the 9 go together, and the 4 and the X go together. So it's going to look like this: sine of 50 over 9, and then that's going to be equal to sine of X over 4. And now you cross multiply, and you're going to get 4 times the sine of 50, and that's going to be equal to 9 times sine of X. And now sine of X is its own piece, so it's going to go down here by itself. So when you do 4 times sine of 50 and then divide by 9, you're going to end up getting this pretty long decimal. It's going to be 0.3405 when you round it to the 4th decimal place. And now you have to do the inverse sign. So what you're going to do is sine inverse of 0.3405. Sorry, I kind of got cut off a bit. And when you do that, you're going to end up getting 19.9. But remember, you can potentially have two answers here. So while one of the answers is 19.9, you also have to do 180 minus 19.9 and get your second answer, which is going to be 160.1. But now we have to see which answer is going to be correct. So what we're going to do over here is I'm going to take this angle 50 and I'm going to add it to my two angles that I just found and see if it's going to be greater or less than 180. So over here, we're going to have 50 plus 19.9, and when you add those together, it is less than 180. So that checks out. So then do 50 plus 160.1, and that's going to be greater than 180. So therefore, it's not possible for 160.1 to be one of our potential angles. So the final answer is going to be 19.9. 160.1 is not an answer. Let's look at number 9 here. Once again, we need to draw our triangle. Label it the same, A, B, C. Alright, so angle C is going to be 75 degrees, AB is 28, AC is 19, and we're trying to find angle B. So once again, try to figure out what all goes together. The X and the 19 go together, and the 75 and the 28 go together, because that's what's across from each other. So we're going to have sine of 75 over 28, and that's going to be equal to sine of x over 19. So cross multiply, and you're going to end up getting 19 times the sine of 75, and that's going to be equal to 28 times sine of x. Sine of x is going to be by itself, and you're going to end up getting 0.6554 as your decimal. And now you have to do inverse sine. When you do that, let's do this first. Inverse sine of 0.6554. And when you type that into your calculator, you're going to actually end up getting 41 when it rounds up. So one of your potential answers is going to be 41. And then once again, you have to do 180 minus 41. And when you do that, you get 139. So these are potentially your answers. So you need to take the 75 that they gave you and add it to the 41 and the 193 and figure out which one is the correct answer. So 75 plus 41, when you add those together, it will be less than 180, so this is going to be an answer. And then you do 75 plus 193, and when you add those together, unfortunately, it is bigger than 180, so this cannot be an answer. So 193 is not one of our answers, only 41 is the answer. Now we're looking at number 11. So just like the last problems, draw your triangle, label it, and now fill in everything. So angle B is 47, AB is 33, and AC is 26. And we need to find angle A. So one thing you may notice right off the bat is that we have this pair right here, but the X has nothing to be paired with right here. So we're actually going to have to find an alternate way to solve for x. And instead, we have this 33 right here and this space right here. So we're going to go ahead and just call that y. And so we're going to solve for y first before we can solve for the x. You have to know what that missing angle is before you can figure out what the side is going to be. So let's set it up. We're going to have sine of 47 over 26, and then that is going to be equal to sine of y over 33. So now we cross multiply, and we're going to get 33 times the sine of 47, and then that is going to be equal to 26 times the sine of y. Sine of y is going to be by itself when you do all of your multiplication and division, and you're going to end up getting 0.9283, and then do inverse sine of 0.9283, and when you do that, you're going to end up getting y is equal to 68.2. And now your other answer is going to be 180 minus 68.2. And when you do that, you get 111.8. So now we have to check both of them. So, alright, so you're going to take the angle that they gave to you, which is 47, and then you're going to add them all together. So 47 plus 68.2 will be less than 180, so that's good, that checks out. And then I went too far ahead. 47 plus 111.8 is actually also going to be less than 180. So we're going to have two answers in this problem. But remember, we're ultimately trying to solve for A, which is, in this case, the x. We need to solve for x here. We've already solved for y. So actually, let me underline this in blue. So the way you're going to find x is because these are both potential answers, you need to subtract that from 180 and the 47. This is what I mean. So what you're going to do is 180 minus 47 minus 68.2. And when you do that, that's going to give you x. And that is going to give you 64.8. This is one of your final answers. Now do it again. 180 minus 47 minus 111.8. Once again, subtract. And when you do that, you're going to get 21.2. Both of these are your final answers. And now we have number 12. So once again, draw your triangle. Go ahead and label it. And now fill in all of your spots. So angle C is going to be 73 degrees. Side AB is 8. And BC is going to be 17. Find angle B, which is going to be this one up here. So let's see what all goes together. 8 and 73 goes together. But X has nothing to go with over here. So same as last time. Your 17, however, can go with an angle over there. So we're going to have to put these together. So we're going to have sine of 73 over 8, and then sine of y over 17. This looks like an H. Let me make that look a little better. There we go. So cross multiply, and you're going to get 8 times the sine of y, and 17 times the sine of 73. Sine of y is going to be by itself after you divide by 8, and you're going to end up getting 2.0321, so it's actually bigger than 1. And then you're going to do the inverse, so inverse sine of 2.0321. And when you type this into your calculator, it's going to actually say domain error. You should see a message that looks something like this. That's not good. Not good. But that means you did do it correctly, because inverse sine of 2.0321, it doesn't process. It doesn't exist. So for this, the answer is actually no solution. If you type inverse sine of some numbers into your calculator and it gives you a domain error, that means that it would be a no solution problem.